it is possible for us to read textual data without actually reading it. So machines will read the textual data. They would do the analysis of textual data. They would tell us what exists in that text. And then it's kind of opening a Pandora's box, because then text is very rich information, and that rich information can be subjected to several quantitative methods of analysis, and it can be subjected to understanding of various disciplines. I know now disciplines like economics, psychology, sociology, political science, marketing, all of them have started looking at textual analysis of textual data, as she would perhaps show you various other kinds of data, like not Instagram, but even Instagram reels or Instagram posts or Facebook posts, WhatsApp forwards, uh, or your Twitter data can be analyzed by using text mining. And this is open data. So, as social scientists, it's kind of a boon to us that you don't have to go and survey people. The data about people is available in the form of text amply. And it is available in the form of books, magazines, Twitter announcements, you name it, and there is a textual data. And it's amazing field of analyzing human data sets. And I think as you would learn in this session, uh, you can also start thinking about how this very innovative and a modern method of looking at textual data can be useful to your work or in your discipline, right? Uh, I Radhika, as you've been a part of this course, you know that people are from different disciplines. All of them are not from psychology, they're from political science, economics, marketing, commerce, uh, political science, psychology, and so on and so forth. So basically, there is a diversity of participants. And text mining is one such thing I'm very sure would be having applications across disciplines. So, yeah, I request Radhika to go ahead and
Hi, yes, thanks. Am I audible to everyone?
you can be slightly louder.
Hmm. Okay. Hi.
Hi.
Thanks. Thanks for the kind introduction. This is definitely a privilege to be um, a resource person for the short-term course. I will start sharing my screen. Mm, yeah, is this visible?
Yes.
Thank you. Okay, so like Sir said, um, I'm going to be talking about how I'm going to give like a brief introduction to what text mining is, and at the end of it, I would demonstrate how a few of the text mining techniques could be conducted on R. Um, the part of R in this case can be slightly complicated, in which case I would be sharing the codes with y'all, and perhaps it would be easier for you to follow if you do the code at a slightly later time when you are more acquainted with R for yourself. Okay, so I'll give a quick outline to what all I would be covering in today's session, and then I would start with uh, everything that I've planned. Okay, so I'll start off with discussing why text mining would be important. Like Vivek sir just said about how it is an emerging technique that data scientists and any other kind of scientists can use in their work. So I would discuss why one can try out text mining for their data and how it would be useful. Given that there is a huge diversity of uh, the participants in this course, I would also look at uh, what would be some of the real world applications of text mining um, that people from various fields can use for their purpose. So, say if I am somebody from marketing, how can I be using text mining? Versus if I'm a political psychologist, sorry, a political scientist or a psychologist, how it could be useful to me. Or if I'm a historian, what is it that I could do with it? So I would look at some um real world applications where text mining could be useful. After which I would look at what are the various sources from where I can um, be drawing such textual data. So usually when we do text mining, the first and foremost step is acquiring textual data. We know that it exists at various places. Um, but also acquiring them becomes a process for somebody who is doing text mining by themselves. So if I'm drawing it from a website, I should know some additional skills for it. Or if I am taking textual data from a book, then acquiring that will have a different procedure to it. So um, that is what I would be looking at in the third section here, as well as in the last section below. Um, so, what are the various sources and what techniques I can use in order to acquire that data from the source? Then I would look at some what are the specific techniques within text mining that I can use. So, usually text mining is kind of an umbrella term and it encompasses various individual techniques that I can use depending on my research question. So, um, depending on what is it that I'm trying to look for in the textual data, I can use one or more of the techniques that text mining can provide me with. So um, these techniques range right from simply analyzing word count in a data set right up till doing topic modeling within the same data set. So they can be of a very basic nature versus more advanced techniques of analyzing textual data. As part of the R demonstration, I would be looking at lastly some Twitter data, um, and I would extract those tweets that have um, hashtag climate change within them, and I would extract those tweets and see what text mining I can do with it. So I would from the basic and advanced techniques that I would be discussing here, I would demonstrate two of those in the last session of demonstration on R. So uh, that is largely what I would be doing. If there is some time left in the end, then perhaps I would show an additional two or three things that we can do with uh, that we can do in order to acquire the data from um, a certain specific source, right? Okay. Mm. So why text mining is the first question that we come across. Now, as a social scientist, from personal experience, we might know that uh, usually we try to make a distinction in research methods and in terms of qualitative versus quantitative methods, right? So quantitative methods will usually have some kind of um, numbers, some data sets, some values which you would be analyzing, versus qualitative methods wherein you would use more interview based methods or um subjective responses from the participants, which you would be analyzing using um, some qualitative method like say grounded theories, thematic analysis, and things like that. Now, the moment we go by the traditional qualitative methods, we hit a roadblock in terms of how much of data we can acquire and the ways in which we can analyze it. Right now, when we talk of the ways in which we can analyze it, um, these methods are usually bound by the subjective interpretations of the researcher themselves, right? So we have certain ideas that we feel are, say, themes in this data set, and we attach those themes to the data set. Over and above, there is only a limited amount of qualitative data that I can typically gather, right? I can, as an individual, I can only hold so many interviews with people. On the contrary to this, what um, perhaps data scientists and other machine learning scientists have lately realized is that instead of simply doing um our classical qualitative methods with participants, there is a humongous there's a humongous amount of unstructured textual data that exists on the internet. Okay, so anything that is text is what um, it exists on the internet, it exists in books, in newspapers, about everywhere that we go, you can find textual data. We may not always have a scale to measure something, but we most definitely will have um, textual data available from various sources. Now, because this data is largely unstructured and also sometimes, or at least once upon a time, used to be difficult to acquire. Hi, yes, Madhuri. Madhuri? Achha, okay, okay. Um, since it once upon a time was perhaps difficult to acquire, all of this textual data has not been analyzed for a while. However, data scientists recently have tried to combine uh, machine learning techniques with textual data that can help us in making um, not just qualitative descriptions of the text, which classical research methods will do, but instead make some empirically based conclusions about the textual data that exists. And that is perhaps why um, uh, text mining should be a useful technique. Um, what we typically do with in text mining is that we get some kind of textual data from various sources, and um, we try to explore patterns, categories, and classifications that can be made out of this textual data, depending on what specific technique of text mining you're using. You should be able to explore what patterns exist in this textual data. So other than just analyzing the text, it can help in predictive and prescriptive uh, analysis of the data as well, since it is combined with other machine learning techniques. Um, there are some um, there are some useful places in which text mining can be and has been used, and has usually been pretty useful to industrialists and businesses, other than, of course, academic research. Um, One of the good examples that I usually like to give with text mining, and why text mining would be useful, is if you consider um, yourself as somebody who has gone to an Amazon website to buy something. Now, when you look at a rating, it will show you a 4.3 out of 5, but you will definitely find yourself, after you've seen the 4.3 out of 5 rating, which is a a quantitative value, you will find yourself scrolling down and reading the reviews and seeing whether you can find additional information of how the product is, right? So you are finding utility in that textual data of an Amazon review um, as a customer. Now, Same thing could be applicable to the sellers of the product who can actually mine these reviews from Amazon and Flipkart and Myntra and everywhere and see and try to find make conclusions out of that textual data, right? So which will eventually help them to say better the product, improve the product, change certain things, modify certain things, and so on. So in such cases, like in customer care services, you will realize that that rating of 4.3 is perhaps not extremely useful to neither you nor the seller of the product, um, as compared to the textual data that exists, right? So we can make more of the information that exists on the internet if we mine the textual data from the internet. Another application of text mining that you will that all of y'all are most definitely recipients of is the spam detection that happens in emails. So if you see your typical Gmail account, you will see that there are three categories. One is your inbox, which is the real people whom you know emailing you. Second is your social media, and third is your promotions. And over and above that, you also have something known as spam, right? Now, every time an email reaches your email ID, there is some machine sitting behind it and classifying whether this email is something that should go to your inbox, that is, whether it is some friend, colleague, boss of yours who's emailing you and putting it in the inbox window, or it will read the email and check whether it has come from a LinkedIn, Facebook, Instagram, Twitter, and put it in your social media tab, or it will check whether it's come from Amazon, Flipkart, and those shopping websites and put it into promotions. And lastly, it will also detect spam, that is, emails you did not technically subscribe to and could be dangerous for your inbox will be classified into your spam folders. So machine learning will keep learning from the new emails that you keep getting and keep classifying the emails more and more efficiently by the day. So say some one day it classified um, a random spam email into your inbox, right? And you mark it as spam after that. So the next time when the sender is the same one, it will automatically classify it as a spam, right? So from your input of marking it as spam, it has learned that this should have gone to spam and do that accordingly. And that decision will essentially be based on the textual content of the email and nothing else, right? Um, there is no specific value that is attached to it which it detects and then classifies it, but rather it essentially reads the textual content, finds what about this is a spam, and then put it uh, into the spam folder. Hmm, is there a question or did anybody raise hand? I heard something. No. Okay. Other than this, we usually look at uh, social media analytics. So, say places like Facebook or Instagram. Instagram mostly has images, and that should also be um, another kind of analytics space. Um, Twitter Twitter is the most commonly used for text mining because most of what Twitter has is text. Um, so one can actually extract um, text from here and see and use various techniques as per the purpose about how, say, what is the sentiment that is going around in the people, or what are the various opinions, prominent opinions of the people. That is something that people have actually actively used with text mining. Um, and that is because social media these days has a huge resource of data, right? And usually we don't end up analyzing it, except for, say, things like number of followers or number of likes that a person gets. But the text content of the um of the profiles could actually be a useful thing to study. So, say I could see whether the textual content of the person can help me to predict how many followers they get, or it can help me to predict how many likes they get, right? So, those kind of things can be very easily done with text mining. Um, Newspapers or books and magazines and even social media places can help me with studying public sentiments um, of a country, of a city, of a state, or anything like that. So there was one study um, which was looking at how during the peak COVID time, what was the content that a president like Donald Trump was talking about versus what is the content that the New Zealand Prime Minister, which is a country assumed to have done better off with COVID at the peak time at least, what she was talking about and what Donald Trump was talking about. So in that case, sentiments of the leaders were analyzed and looked at how they were talking about it. In insurance purposes, fraud detection is also something that is um, a frequent use of text mining. Usually, in fraud detection, you use not just text mining but also other machine learning techniques of regression trees or cluster analysis as well. So, fraud detection is a slightly more uh, a place where multiple techniques of machine learning are used, one of which is text mining. Okay. So, what are the places, if I have to brainstorm about where I can draw textual data from? Now, this is a slide that will at some place be limited by uh, my boundary of my discipline. However, if wherever it is in your discipline that you can find textual data becomes a point at this slide. Okay, so um, this is presently um, my understanding of the things that I've come across before, but there can definitely be a lot more than only this. um, so we can obviously one very rich source of textual data will exist in books, magazines, and newspapers, um, which exist in libraries, which come to our home every day. There's ample of textual data at these places. Um, there are websites which have um, a lot of textual data themselves. Say people who write blogs, people who have their own personal websites. There are government websites also that you can text mine. Um, Slightly controversial, but do it at your own risk. Um, there could be any kind of websites basically, and one of the subsets to website are social media websites. So one can draw data from Twitter, Facebook, Instagram. Um, Often email threads are also taken in order to from companies. You can uh, have email threads and analyze those content. Yes, Umesh sir. Umesh sir.
Can I ask?
Hi, yes, Rekha madam. You can ask. Rekha madam, you're on.
Yes, ma'am, audio speeches are the primary data or secondary?
Depends how you are drawing it. It can be primary data also, or it can be secondary data also. So if,
Recorded by government, I think so.
sorry,
AIR, recorded by government means AIR.
yes, those can be taken depending on the permissions that are provided by
Yes,
them.
correct.
They can be. So if I'm drawing a speech um, YouTube, then that becomes an open source place where we can draw speech data, audio data from.
Correct.
Yes, Umesh sir, yes. Okay. Um, Twitter is something that is usually open source. वहाँ से you can, जितना I've studied, Twitter data can be taken without any ethical issues. Facebook and Instagram does become a problem. Also with Facebook and Twitter, drawing data is also problematic because you need a login into the person's account in order to draw it. तो वो allow नहीं हो पाता है usually. Facebook pages can be taken because they are open accounts, and even on Instagram, if it's an open account, then usually there is no such issue. And and also, like one example that I have personally done is about text mining books of the Hindi language. So when that was done, there is obviously a copyright issue that comes into account. So in those cases, one should perhaps look at the publisher and see whether there are copyrights that are broken off after a certain number of years. 50 years in our country is, I think, the copyright of over books is broken off. So after that, those books can be text mined and things like that. हाँ बिल्कुल sir.
Yeah. Radhika, I had a question, and I do not know if I'm asking too early. Probably you may cover it up later. But because you're speaking about sources of data, I just wanted to ask because a lot of people might be here from history and other areas, and because most of the data sources you are pointed out here are available in digital form. Even newspapers today are available in digital form, right? But what about suppose if I'm looking something like an archival source, where it may be some old printed material, typed material or something like that, and I need to scan it. So, does text mining then also work on scanned documents as such?
Yes, it does. That is the next slide.
Okay.
I'll come to it. Yeah, yeah.
Thank you.
Thanks. That was a very major roadblock that we encountered when we tried doing it. But yes, there is a way out for that.
Okay, thank you so much.
Yeah. And lastly, audio speeches are interviews that we may conduct, or as Rekha Madam was saying, they can also be secondary sources of data, which can be drawn from open source websites. Say, YouTube is, I think, one of the most uh, common source of audio data at the moment. So yeah, those can also be taken. Now, the problem that occurs when taking data from all of these sources um, is that all of these data is not always text mining friendly for us. Like Wilbur sir was saying, um, you may have books that exist in your bookshelves, but you will have to scan them. And once you've scanned them, typically scanned pages are not readable in softwares, right? So you need better techniques in order to data saved from this book, how can I exactly bring it to a format which will be read by my software? Say if I'm using R right now, how do I bring it to that format, right? So um, there are some other useful techniques or skills that that a researcher can acquire in order to bring that textual data into a text mining format. Drawing the data from, um, you will know some additional techniques. Now, what are those? Now, when Wilbur sir was saying was talking about archival data, which exists in books, and perhaps you need to scan it, or you have scanned books that exist on the internet that you wish to use. You can use a technique known as optical character recognition, which is basically a technique. You might have seen this in your phones, wherein you scan a page of text and it reads the text inside of it. So you can use a software like R to do this OCR on a much larger scale instead of just some individual pages, because since it's a machine learning technique, you will have a lot of data at your hand, right? So to do it on a large scale, you can use softwares like R and Python um, in order to do an OCR, that is character recognition. Um, if you're drawing data from websites, okay, say from blogs, um, or any other open source website, there's something known as web scraping technique that will come handy, which is essentially web scraping is putting a link or a URL into an R code and telling the R code to extract what is on that website. Okay, that is basically what web scraping does in short. You can use web scraping with Twitter. You need um, separate packages that exist are to get extract the tweets. Sorry, you need specific packages when it basically authenticates your Twitter account, um, and that this device of Twitter can draw tweets from the website. That is what one would do. That is also what I will show in the R demonstration with Twitter. Um, Twitter ka link, it was an invalid URL. You need to go to Twitter for that. So that is one. And if we are taking data from um, audio files, speeches of people, then we might need some kind of a transcription system which can uh, listen to the audio files and provide transcriptions of it. So as of now, in R, you can do transcriptions of audios, but description of interviews from other languages, say Hindi and so on, right now not possible. Maybe Python can do it, but that's not a skill I have, so I would not comment on that. Whether Python can definitely do it or not, I'm not totally aware. Okay, those are some. So if I have to in the intro some demonstration of OCR, where you draw text data from multiple sources of books. There is another component there. I will agree to that. When I checked for how many error OCs, there is a percent error of reading that OCR does do. Rest 90 is largely accurate. Um, However, if we have a large pool which from where we are drawing data from, then the error should be that. That is how OCR becomes used when doing text. What are the techniques that I can use to do text? Set um, is more of an umbrella. There are specific techniques that I uh, to do text. Okay. Now some of the um, very techniques for um, text mining is word frequency. So taking a large pool uh, data and seeing frequency of every word. So how many times does the climate occur in this data? How many times word proper in this? 10 words are there in your, it would frequency of each of those words. Okay, word frequency is. Slightly more advanced to word frequency is what is known as n-gram analysis. Now, n-gram is also known as bigram, depending on how it is used. What n-gram basically does is it studies um, which pairs of words occur together. So every word that occurs together is taken into a pair. So say I have a sentence that reads, "My name is Radhika," right? So, and if I'm say I'm studying bigram analysis, which means I have to pick pairs of two. So my first pair in the statement, "My name is Radhika," will be my name. My second pair will be name is. My third pair will be is Radhika, right? So throughout the textual data, it will see how many times my name comes. Then it will see how many times name is comes, and then it will see how many times is Radhika comes. So in this manner, in the entire textual data, it will see how many bigrams can be made and how often one word is associated with the other word. Okay, so now this was a super simple statement that I made. But say if I take a slightly more common, uh, slightly more sensible statement, then say how many times does the word climate change come together? Okay, or how many times does the word prime minister come together? So this means once prime minister commonly being used, while um, prime did not have any other associated word a lot, and minister did not have a lot of other associations with anything. But prime minister together was a very common phrase that was being used in the text that I was looking. Now you can either do bigrams, or you can also do more than um, pairs of more than two, basically. So depending on what your n-gram it is, you can make it 3, make it 4, or you can make it how. Usually, 2 to 5 words. Okay, wait. It gives you an association between there is slight mathematics to it. I'm not getting into for this course. Gives you an association value between. Now, um, now word frequency was a technique wherein individual words were being analyzed. N-gram is a technique where pair or being which was saying one word text in which a word is being used. Any kind of language, you would realize that the same word can be used in different contexts and all in different things. Using learning algorithms, concordances can track in or in word being used more frequently, less frequently, and so concordance tries to do. Now, definitely with all of these techniques, one disclaimer I would like to make is that um, clear machine learning algorithms in the background that they make use of, which given the structures I'm not getting into, and simply trying to make an orientation to what um, one can look for um, if such kind of technique is useful to your research question. That is my basic aim with the present presentation. So yeah. Now slightly more advanced techniques include topic modeling, sentiment analysis, and opinion mining. Topic modeling is something that just like how in qualitative analysis we try to fix data, topic model does the same thing using some amount of some good amount of machine learning. So it tries to identify what kinds of topics are frequently spoken about in a certain kind of data. So say tweets from a bunch of young people, I would find say related to food, fashion, some on education and college and so on. Right? So these would be the broad topics. So modeling is in a way that it has a kind of and once a word is in a certain tweet, it would add to a topic of say food. So if it reads the word burger, then the topic of food will get an additional point. If it reads the word college, then um, education would get one extra point. Okay, something like that is what um, topic modeling tries to do. And it is as simplistic as I tried to explain it. It's not not that but clarifies what topic getting. Something that I have used is what is known as sentiment analysis, which, like I said, I was an example public science as a application. Um, Sentiment analysis is something that might be useful in such a place that what people are when they talk about a subject that is prevalent in the society. How are people talking about um, um, the Ukraine-Russia war, or how are people talking about the leader of the country? How are people talking about um, climate change in the world, right? So how people are feeling the sentiments of the people when they are talking about a certain issue that is there in whatever the research question is, whatever the issue is. How are people talking about it? How are people feeling about it is what sentiment analysis will um, give you. Now, sentiment analysis can be done um, in a couple of ways. So, sentiments could either range from positive to negative, right? When talking about climate change, sense and negative. While talking about travel and tourism, positive. Okay, but we quickly realize simply classifying sentiments on a spectrum of positive to negative is slightly shallow in itself. Hence, maybe making finer discs or categories in sense will be useful while doing sentiment analysis. So, a different method of sentiment is we classify text into various sentiments, say anger, disgust, fear, happy, joy, sadness, and also positive and negative. Okay, so there are different dictionaries which we can use in R, which I will show, which would be useful in doing sentiment analysis. Okay, so it's not sentiment analysis. Then is not just one technique in itself, but um, it is one way of doing text mining, but it can itself be done in multiple ways. So that is what sentiment analysis is. And opinion mining is again somewhat similar to sentiment and topic modeling itself, but trying to make opinions people a certain realization about a certain topic. Okay, that is what opinion mining also does. From these techniques, while demonstrating them in R, I would be looking at two things for today. One is word frequency, and so that's one of the basic techniques, and one advanced technique of sentiment analysis. Okay. So what am I demonstrating in R today? When we go to Twitter, we one of the popular things with Twitter these days, also with Instagram, is a hashtag. So a hashtag basically provides us it provides us to group different tweets together, which are on a common topic. So there are various ways of looking for Twitter data. One is for mining a specific person's handle. So say I am mining only Donald Trump's handle, okay, and looking at whatever he says. Or I can mine Twitter data by using a certain hashtag. So I could say search for a hashtag of climate change. I could search for a hashtag of Russia-Ukraine war. I could search for a hashtag of India, right? So broadly, these are the two ways in which data from Twitter can be acquired on in R, and the acquiring of data is done, one can proceed to um, analyzing it with whatever techniques they wish to. Okay, so right now I'll be looking at um, Twitter data, um, which which contains of those tweets which have the hashtag climate change in them. Okay, so these are just some random examples. I will be extracting 10,000 tweets from Twitter that have the hashtag of climate change on them, and then analyzing those tweets on R. So we can go to R Studio. Is my R Studio visible?
Yes.
Okay. So to do mining, I'm going to need, like I said, I need a bunch of libraries to text mining. When I send y'all the code, y'all can simply run the entire code and you will get the output as I. Could you zoom it? Yes, definitely. Zoom कैसे कर? So, okay. This enough, no? Should I? Okay. So I these is really ggplot is a library that helps me to make very pretty graphs. So ggplot is something that once you're familiar with basics of R, it's a library that one should definitely learn. And it helps in making some really personalized graphs. You can make a graph as you imagine it, basically. And it's a very simple to use library, ggplot. That is what that will help us to do. Dplyr and tidytext also are two libraries that help um, in arranging textual data in a certain format that you want. Um, and dplyr typically is for arranging any kind of data set into a certain format. So all modifications and games that you want to play with your data set, dplyr will help you to do it. And tidytext itself has a bunch of text mining algorithms fed into it, that will help you to run different kinds of text. And gggraph two libraries that are make some kind of plots, which is why I installed them. And the last two packages of Suzette and Sentiment are two packages that you require for doing sentiment analysis. So Suzette is a popular package used for sentiment analysis, and Sentiment R is also a popular package used to do sentiment analysis. Okay, I'm going to begin with calling the libraries.
Ma'am, in our we'll have to first install them.
Yes, that is what these. I was this I will where I will later log in. So the first time you required to go to your Twitter account, authenticate it to be able to extract tweets. This code will work right away. If you perhaps it for you. Um, what happens account and perhaps it work. So here is drawing climate. Okay. Saying that you should extract that have hash, you have to 10,000. It is 10,000 because 1,000 nikal ke there is no good purpose. Hence, you have to take it as 10,000. Draw it's in the English language and discuss showing the R code, and whether I should include retweets and calls, because then it will do duplication data, right? So if I am tweeting climate crisis is real, and there are 1,000 people who are retweeting me saying climate crisis is real, it will basically end up duplicating data that I don't want. Okay, that is why I'm saying include retweets is equal to false. Okay, so I'm going to run this, and this kind of takes time. It's at 4%. It will 100%. Still, then, if anybody has a question or something, they can ask. A regular Twitter account would do for this library. There are other libraries, one of them which is known as TweetR, which needs an API from Twitter, which is why I'm not demonstrating it for today. Yes, Shahnaz, my name is.
Ma'am, meanwhile, can you just copy paste those commands, that install and library thing in the chat?
Yes, yes.
We can do the needful.
From here, just remove all the hashtags, otherwise it won't run. Yes. So my tweets have been extracted. It
Thank you, ma'am.
shows, yeah, it shows 100% here. Now I'm just going to quickly look at I'm going to look at the first 6 entries of this object. The climate tweets that has been extracted. I'm going to look at what all it has. Okay. So, okay. Now IPCC is going to be a popular thing in this R code that I have, because IPCC report came 2 days ago. So a lot of tweets are around it. So say there is one tweet that reads the latest IPCC report is out, read about the need for climate resilience, water resource management, and so on. So mm, these are some of the tweets that I've gotten. Head, the command head, is showing me the first 6 tweets from this data set. Otherwise, you can see here there are 10,000 observations of the climate tweets. Okay. Now, what happens when you take data from Twitter is that there is always a URL at the end of it. Okay, so there is this HTTPS something that is the URL of your tweet. Okay, I don't want this for my text mining purpose, because HTTPS leke what am I going to do? I'm not interested in its frequency, in its sensitivity. So I use the next line in order to remove all the HTTPS and all other URLs over here. So gsub is a function that helps me to do that. So first, there are 2 kinds of URLs. One is HTTP and one is HTTPS. So I removed both kinds of um, both kinds of URLs I remove. Okay, and then if I do climate of and I do head climate tweet, those URLs will be gone away. Yeah. So from here, if I now check the stripped text object, I will see that all my URLs are now gone. Okay. Second thing that I do is I remove punctuation, so things like full stop, question mark. I bring everything to lowercase, because what happens if I write the word Radhika with a capital R, and then if I write Radhika with a small r, both of them will be detected as 2 different words. So I need to bring everything to lowercase for text mining, because then it will keep computing different frequencies for small and capital letters, right? So I do that with this one, which I call now climate tweets clean. Okay. So my climate tweets have been cleaned with that. Um, and then I plot the top 15 words from this data set. Okay, whatever cleaning I have done abhi tak, I plot. Now I've moved to computing word frequency basically, wherein I will plot the 15 words with highest frequencies of them. Okay, so I run this, and this is what I get. Okay, so it is telling me that the word the has appeared most number of times, followed by climate change, because that's the hashtag, followed by to, of, and, is, in, on, for, will, and so on. Okay, now I have an obvious problem with this. It is giving me words that have no meaning for me as such in terms of text mining, right? I don't want to know the frequency of the word the, right? So for this purpose, what I need to do as an additional step of data cleaning and text mining is removing what are known as stop words. Okay, there is a list of stop words given in the tidy text package. So if I just see this data set, then you'll see, yeah, these are some of the words that are classified as stop words. Okay, so the word a apostrophe s, the word about, above, according, all of these words will be removed. Okay, so I run another command, this one, wherein I tell it that from the climate tweets clean data set, you remove the stop words. Okay, so I will remove these stop words and I will run the Uparwala graph ka command again. The one that gave me this, I will rerun it and see what change happens. Yeah, now I see that I have a different set of things. Climate change is the winner, definitely, followed by climate, report, change, IPCC. Yesterday, IPCC was much below for me. So last night when I was running the same code, IPCC was somewhere here. Today, it seems to have crossed the 1,000 mark clearly. Yesterday, it was under 500. So as the IPCC report is being read by more people, it is climbing up in the graph as well. People, impacts, energy, world, global, future report, and so on. So I'm getting the first 15 words that are most commonly used from this Twitter data set. Okay. Now this was my word frequency. Just seeing what are the most commonly words, what are the most common words being used for by people when they're talking about climate change. Okay. The second technique that I would demonstrate is what I said is known as sentiment analysis. Okay, so what are the common sentiments that people have about this issue of climate change?
Sarika, do you have a question?
Yeah, just Radhika.
हाँ मुझे सुना ही नहीं दिया हाँ बोलो
Because climate change is the highest frequency. Is it because of like you've taken the tweets from climate, like hashtag climate change? So is there a way that you can like remove it? Because of course that will be the highest frequency.
हाँ correct I think either climate change will need to be appended to the stop word list is one way, or we can remove it from the graph and further analysis after the analysis is over. So once we've gotten the word count for everything, we delete that observation for further analysis. These are two ways I can think of in order to do it. Umesh sir, you also raised hand. Can anyone hear
No,
me?
it is, I think, by mistake, is what he's.
Oh, okay. Yeah. Yes. Okay. So I can either. Yeah. So if I just take, so I created an object known as climate SENT, wherein my output for sentiment analysis is stored. Okay. Okay. And if I run that, I can see that I have 418 anger words. I have 394 anticipation words. I have 306 disgust words. I have 517 fear words and so on. Okay. And to make it slightly more friendly to view, I can plot these scores of sentiments on a graph and make a bar plot out of it, wherein I can see how people are understanding sentiments. So fear is one large bar over here in terms of classification. There is little joy about it, definitely. There is also little surprise about it. It's as if people had anticipated something like this to happen. There is also a good amount of anger words that can be seen between the people. And negative and positive, you will notice frequently that they will be the highest bars. And that is why I didn't particularly start talking about them to begin with. And that is one of the problems that has been noted about sentiment analysis of this kind. And that is the fact that the score of positive is technically a combination of joy, surprise, and trust. Okay, so वो तीनों का मिला के it will make a score for positive, and the negative scores is also a amalgamation of sadness, fear, disgust, anger, and so on. Which is why basically one word falls into multiple categories, which is kind of problematic for sentiment analysis if you're looking at independent categories of or if you're expecting categories to be independent of each other. So that is one problem that has been noted with sentiment analysis. So usually I like to ignore these and perhaps look at what these specific positive and negative emotions are telling me. So yeah, so that is sentiment analysis. And now I come back to my original problem of when I'm writing language English, and that is the fact that as of now, um, whatever packages, softwares, and techniques and dictionaries and data sets that we have for text mining purposes, no matter which technique you're using, whether you're doing sentiment analysis, topic modeling, or opinion mining, anything that you're doing is as of now limited to the English language. Probably there are packages for other European languages. I am not sure completely about it. But if we are coming, while all of us are coming from the country of India, I have not come across any package that is able to do sentiment analysis or text mining of any kind on a data set of the Indian language. Okay, so Hindi included, if that is the largest spoken language of the country. Hindi included, there is no such package that is able to do, say, sentiment analysis for a Hindi data set. You can definitely compute frequencies because frequency is a frequency. You don't need a meaning attached to it or anything like that. So we can definitely do frequencies for a data set in Hindi, Marathi, Gujarati, anything can be done if you have textual data available. But you may not be able to do text mining in terms of sentiment analysis or topic modeling or any other kind of natural language processing as of now. Okay, so like we began the session by saying that it is an emerging technique, I would also um, reiterate the same point in the conclusion, stating that it is still an emerging technique and has perhaps not evolved to an extent of being exploited at a very large scale yet. So we're using it, data scientists are using it, but it is still limited to a certain kind of language, which is a problem. If we are talking of textual data, there is a lot of textual data that exists in various languages. And if we restrict ourselves to only analyzing English and Mandarin data, then perhaps we as scientists are at a loss. And more advanced programs or more advanced packages in R in Python that might be able to analyze Indian languages might be useful for us as academicians in this country is and yeah, with that, if if anybody has any questions, I can take this.
Alok Nanda Ghosh, you've raised hand, so you can go ahead.
Hello, ma'am. My question is, can we do sentiment analysis in terms of qualitative statements that we are collecting from field survey, something like that? From the respondents, sometimes we take statements. So can we do that?
Definitely, but it would be desirable if there is a larger data set that we would have. Matlab, the more the content that is available with you at hand from the interviews, the better results you would get, since it's a machine learning technique after all.
Okay, thank you, ma'am. Ma'am, then we need to bring them into number.
No, you don't need to. You need to input the textual data into R. You need to import it as a CSV or a PDF and then analyze it, and then it will give you the number after that.
And can you please show us how to do it if you have time?
I'll send you a code wherein PDFs were imported and the PDF ka jo content hai, that is being analyzed. I will send a code for that.
Okay, thank you.
Shehnaz, you've raised hand.
Ma'am, could you please repeat the interpretation of the word frequency thing? How do you interpret that data?
It's basically frequency. So how many times was the word climate used? So wait, I will share screen again. This one, right?
This is the only analysis possible, that we give the number of count. That's it.
For yes. For what frequency? This is it. You find how many times climate was used. You find how many types report was used.
So, ma'am, basically, we cannot do any testing as such with this. It's just the words we are counting.
For this specific word frequency, there is no hypothesis testing as such that is done. With things like n-gram and topic modeling, there are other structures of data output that you get, but there is still no hypothesis testing in it. Okay. In any of the techniques. Yeah.
Okay. Ma'am, will it be possible for you to share this script with us?
This one, right?
Yeah.
Yes, definitely. I will send this, and like Alokananda has asked for how to import, say, CSV or PDF data, that also I will.
Okay. Thank you.
Share. Yes.
Shehnaz, perhaps the statistics that you are thinking of doing can be done once we have data, right? See, what you're looking at is analysis of data, right? But if you look at a textbook, where is data? So you have to convert the entries in the textbook, which are in the form of words, into numbers. Once they are converted into numbers, then you can use some statistical model on that data. So, for example, I can take two novels published in 1950s, or five novels written by one author, five novels written by another author, and then I can ask a question that in these two sets of novels, what is the correlation of a sentiment called, say, trust, if I can code that sentiment? Or I can ask more complicated questions, that can I predict, if one author is later, the other author is earlier, can I write a predictive model of the influence in terms of textual similarity that the two authors will have? So I can then have those kind of models. We are doing similar such analysis. Me and Radhika, we are doing this, and we are also building dictionaries for that. The problem she has mentioned, that there is no Marathi tool or Hindi tool available. So at least for Marathi and Hindi, we are working on it. And what you can actually do is you can set time series analysis. Personally, I have written a paper on COVID data, which is in publication, wherein we have used time series analysis on Twitter data. So the statistical model that you're using on a data depends on what do you do with the text. What Radhika was basically saying is, if you have a text and if you want to know frequencies, this is what you can do. And
Okay, so
that's the
this is
first.
basically we are creating the base for the next step.
First is you create so the biggest problem, biggest hurdle social scientists will have is, if we will have textual data, but how to convert that textual data into sentiments or frequencies or topic modeling, or in fact, today we can think of more complex things using uh, deep learning techniques, uh, uh, more deeper structures of interconnectedness between the sentences. Right now, what we are looking at, honestly, in text mining, we are looking at word. We're not analyzing sentences. But it is possible to analyze sentences. Like Google does that, but it is not accessible to you and me. In the sense, those codes are not publicly shared. Those computational capacities are also not there in the computers that you and I have. Okay, they write models like in morning. Anurag was showing models with say 3 predator variables. Google, in fact, in one of their reports, said that they have some billion predators in a model, and they run those kinds of models. So, what we are doing, or the biggies are doing, is still not like within our reach. The point is, these biggies also know how to look at the research questions that you and I have. They are doing it for the marketing purpose. So if I have a question that what is the nature of personality in natural language, or uh, how economic thought is expressed in 18th century literature, okay, or how feminist Marathi authors write differently than men authors who do not take a feminist stand, right? Uh, all these questions are important questions, and these are questions in social sciences, right? So there we can still do things, and we can use analysis. In fact, Google has also provided a lot of tools, like Ngrams is available in Google. No, you can use Google Ngram and get the data. So it can be your input data. But Google Ngram is only again in limited languages. Yeah, that's it.
So, sir, basically, may I?
Yes.
So, sir, basically, this my interpretation is that we are creating the base for the further processing, right? For further hypothesis testing and modeling. These two steps, what we did.
Yeah, in these 3 steps. In
Yeah.
fact, we didn't have a session on how to do further analysis, because it
Okay.
would be like again repeating some kind of logistic regression, repeating some kind of simple regression or correlation. So that we didn't want to do like the same kind of repetition. Radhika, do you have any other response, please?
Like one of the examples with social media, an addition, not another response. Um, like when I was giving an example of social media, I said how I could analyze the content of every Facebook account and make a prediction of how many followers they have or how many likes do they get, and things like that. So in that manner, my text mining analysis will serve as a feeding in of some kind of data in order to make a predictive analysis of some other dependent variable, wherein I would use my regression techniques that will be appropriate in that case. So yeah, that's how, like you're saying, one can create a database of a set of variables and use it for further analysis. Hmm. From Amazon, Flipkart, you have to use web scraping packages, web wherein you will basically enter the URL of a package, the URL of a website, and tell it what all to extract from there. So from Amazon and Flipkart, that can be easily done. There is a library known as RWest, which helps you with web scraping. Library called RWest, which will help you with web scraping, and Amazon and Flipkart data can be retrieved through web scraping easily.
There's no one asking a question. I will quickly share a screen and show you something. Because Shayana was asking about data analysis. Look at this. This is a paper on first 100 days of pandemic, and this is the two emotion responses across countries. So everyone is a country. Okay, and this is a list of country, and this is done purely by text mining. There's nothing else. So we did not go to people, supplied questionnaires and stuff like that. All of this is just doing text mining, obtaining things, and then there's a time series analysis done about this data. So, all of this possible. This paper by me and one of my colleague from UK, uh, and that's something is very amazing capacity that text mining provides us. Otherwise, I can't go to 100 countries and ask them, how are you feeling every day, right? This is possible only if I could simply look at the text from those countries and analyze the data. Yeah.
The text was the newspaper articles or it was
Twitter. Twitter provides a region. That's the beauty of Twitter. It tells you which country the tweet has come from. So there are certain facts Twitter gives along with the data. Now, as Radhika has already said, that there are limitations. Any source of data there is limitation. You make questionnaire, people can tell you things that are not true. Like I ask people that, are you an anxious person? People say strongly disagree when they're actually anxious. So every data collection method will have flaws. Like when we do surveys in rural areas, the first question they would ask you, इससे हमको क्या benefit होने वाला है? Right. Depending on what benefit they're going to get, they will give their answers. So आप उनको बताओ कि this we are doing for a yojana, if which perhaps will be given to people who are poor, they will end up telling how poor they are. Right? And you tell them that this is going to be for educated women, and then they'll give you detailed information about how well educated and how qualified those women are in their household. So any kind of data you collect, any method, the point is not about the motivation. The point is you choose any way of collecting data, it will come with its own flip sides. So is with the textual data. Like if you take Twitter data, half of my country doesn't use Twitter. So 80% of India is not represented in data. Right? But still, at least that 20% that is represented is the part of people I am making models for. So every kind of research will have its own limitation. We acknowledge it and move on. Yeah, it's 3:31. I thank Radhika for such a wonderful session, very different topic. She's such a young and amazing researcher. I keep whenever I work with her, I keep learning new things from her. So thank you, Radhika. We'll take a break for say 10 minutes. 3:41, 3:42, we'll come back. And then we have a lab means we are going to do basic R once again, because I know all of us are at different levels when it comes to R. And since our project coming up, presentations coming up, all of you are going to do presentations in a day after. So to brush up R for everyone, this R session is kept. Radhika is going to continue with us. Now you know that she deals with R really well. So she would perhaps take us through the lab sessions and R again. So see you at 3:45. Yeah. Thank you, Radhika. Thank you, everyone.
Thanks.
Thanks.